Okay, this is the second video for section 4.2, Advanced Geometry. Colin, Garrett, I hope you're watching this. Given these two triangles are congruent, find the values of A and B. So, just saw angle B first. That's this angle in the picture right here. That is angle K. So I'm going to go back to the congruence statement. Angle K corresponds with angle S because they are the last letter written. So angle S is up here, but I really don't know anything about it. So can't do much yet. So now I'm going to go to angle A. That is, or where the A is, that's with angle T. T is first, so it's going to have to correspond to H. Nice, I know what H is. Okay, because these triangles are congruent, because angle T corresponds, or vertex T corresponds with vertex H, angle T is congruent to angle H. So, angle T, 6A, not plus, minus 3 will equal angle H, which is 51. So 6A equals 54, just solving for A. Divide by 6, we get an A value of 9. That's part of our answer. Okay, so now we need to go back and talk about how to get B. We said that angle B, well, what we said was angle K was congruent to angle S. So in order to get B, we need to know what angle K is, which means we need to know what angle S is. So we're going to focus in on this triangle up here. We just figured out what angle A was. Or what variable A was. So we're going to go 6 times A. Well, we don't even need to do that. 6 times A minus 3. That was what we just found out right here. That was the 51. So angle T equals 51 degrees. We know angle R is 83 degrees. We're looking for angle S. So those are the three angles of a triangle. So angle S plus 51 plus 83 equals 180. So we got, I'm going to subtract the 83, that puts that at 97. Then I'm going to subtract the 51, puts us at angle S equal to 46 degrees. Okay, angle S, 46 degrees. So angle K and angle S were equal to each other. So angle K was 7B minus 10. That equaled angle S, which we just found out was 46. Here's how we're solving for B. So add 10 to both sides. Divide by 7. We get B is 8. There's our values for A and B. So with this problem, you're always looking at, you really got to be using the congruence statement. All right, this statement up here tells you which angles are going to correspond. Maybe you're given side lengths. It tells you which sides correspond so that you know these two are going to be equal to each other. And so it helps you guide what you're looking for. All right, for this proof, just filling it in, we're always starting with the given information. So we are trying to prove these two triangles are congruent to each other. We've only got two triangles in the picture. So in order to prove two triangles congruent, for now, we just got to show we have every corresponding angle congruent, every corresponding side congruent. So from the given information, we've already got a lot of stuff. We got one pair of angles congruent. Angle ADB was congruent to angle CBD. There's one pair of congruent angles. The double dash is BDC. That angle was congruent to angle ABD up here. So there's two pairs of congruent angles. We need the third pair, which is going to be angle A and C. Well, we can make that statement now. Angle A congruent to angle C. And I can use the single letter because at A there's only one angle. At C there is only one angle. The reason these two angles are congruent, we've got the other two pairs of angles congruent. That was the third angles theorem. What we talked about in the first video. Third angles theorem says you got two pairs of angles congruent. The third pair have to be congruent also. All right, so again, we're trying to prove two triangles congruent. So we got to make the statements that we have all corresponding angles congruent, which we do now, and we need to say we have all three pairs of corresponding sides congruent. And we basically have that in the given information. AD was congruent to BC. AB was congruent to DC. The third side is DB. Well, it's the same side in both triangles. This is where we use the reflexive property. Segment DB is congruent to segment DB. It is a single segment in this picture, but we're using it in two separate triangles. And this is the reason that we use that reflexive property. All right? It is one segment. Oops, reflexive, it's a V. It is one segment, but again, it's in the context of it's in two different figures, and so we have to say it's congruent in both figures. So that's the reflexive property. It's the first time we've actually used it when we really needed it. We've got three pairs of angles congruent. We've got three pairs of corresponding sides congruent. And they're all written in our statements 1, 2, and 3. So statement 4 is now what we want. Triangle ABD congruent to triangle CDB. Pay special attention to the order of the letters. Keep everything the same. And the reason this is true, this is the definition of congruence. All right, to prove a figure is congruent, or two figures are congruent, we need to show all corresponding parts are congruent. And we have that. And that's the warm-up that we'll be doing in class on Monday. Have a good weekend, everybody.